And now,
All right.
time for something completely different. So, I always love games, and I love it when students create games because, well, I love playing games, and I've made it one of my jobs as an instructor to always try and be top of the leaderboard on a student's games,
That's great. Yeah.
which is tough unless it's deployed because then I'm only in the development database. But I love games, not just because they're fun to play. They can be very technically complex to manage. There are architectural issues, there are state management issues, there are gameplay issues, and it shows JavaScript's flexibility as a programming language that you can create something like Boomerang, you can create something like Workit, and you can also create something like what we're about to see, which is a fun game called Death Road to Toronto.
Hello, everyone. My name is Albert O. I worked with Sky Mason and Steve Nguyen to build our app, Death Road to Toronto. The main purpose of our app is to survive and collect points by shooting zombies. When the user enters our game, they spawn at a certain location. After spawning, multiple zombies will chase the closest player. Once enough regular zombies are defeated, a boss zombie spawns to challenge the players. Each player also has ability to switch between 6 different weapon types, each with different range, ammo, and damage to the zombies. Our app is in browser real-time multiplayer survivor game. We're inspired by a popular survivor RPG game called Death Road to Canada. Our app mainly uses Phaser along with Web Speech API on the front end to provide sprites, animation, voice recognition, and core design of the game. Meanwhile, we have Socket.io, Express, Node.js, Postgres, and SQLite on the backend to allow real-time interaction with other players. Now, I'll pass it on to Sky to talk in detail about the gameplay and the mechanics behind our game.
Thanks, Albert. Continuing on to the gameplay technologies and mechanics behind the game, we primarily used Phaser. Phaser granted us access to many built-in methods and mechanics such as sprite-based animations and collision between sprites. One of the biggest gameplay challenges was creating objects that could collide with each other. In our game, zombies, players, buildings, and missiles all have unique collision patterns determined by what they collide with. Through Phaser's built-in grouping of sprites, we can manipulate collision behavior and how that affects gameplay. Through tracking player position and creating a bitmap around each player, we were able to emulate a darkness effect that restricts player information and field of view. We also added a rain effect by generating smaller bitmaps which represented rain particles. By emitting random spawn locations with associated x and y velocities, we were able to mimic natural wind and gravity. Another feature we were able to add was voice recognition through Web Speech API. With this technology, on Chrome, users can say shoot and their players will shoot their current weapon. Another command players can use is weapon switching. Players can say the name of any weapon and automatically switch to that weapon. Integrating in voice recognition was a challenging process, but added a unique aspect to the gameplay experience. Once a player dies, their score and name are added to a Postgres database using SQLize ORM, which is read and displayed on the scoreboard. The scoreboard allows for competition between players despite the cooperative nature of the game. To explain more about how we translated these elements of gameplay from single player into a multiplayer experience, I'll turn it over to Stephen.
Thanks, Guy. One of the biggest challenges we faced while developing our game was deciding how to implement multiplayer. We decided to use Socket.io in order to control server and player communication. In our application, each player has their own game instance, and whenever there's a change to their location or health points, they emit that change to the server. The server takes note of these changes and then broadcasts the changes to all other clients. Each client then individually renders all their sprites dynamically based on information received from the server. When our game was still single player, we had each player have their own set of zombies. However, we realized that once we implemented sockets, we no longer wanted zombies tied to individual players. We decided to handle zombie behavior on the server side in order to keep enemy movement consistent. We achieved this consistency by deciding spawn location, pathing, and target selection on the back end. We hope you enjoy this demo of Death Road to Toronto. Please feel free to prep for the zombie apocalypse at deathroadtotoronto.herokuapp.com, and thanks for listening.
Yeah, it was very nice, very well done. The graphics and the the gameplay itself seems like I like the WebSpeech API aspect to it too. I think that's kind of a cool
Yeah, sorry, you might have heard me shout machine gun and chainsaw a few many times while you're walking by. Yeah, I love this game. And the fact that it's multiplayer, that they've had to think about what is being calculated on the server, what's being calculated on the client. Yeah, it's a good app they've built here.
All right. All right. Reminder, if you're into games and you're into Death Row to Toronto, please feel free to vote down below for the pinned comment on Facebook.